Less attention has been given, I would say, thus far to the sustainability side of things. But of course, there are people trying to really think about how we can use biomimicry for sustainability.
Welcome back to the Sustainable Healthcare Podcast. My name is Lasse. I'm a senior consultant with Green Innovation Group. Today we're speaking again with Ayla Kiser, who is an expert and researcher in biomimicry and nature-inspired innovation. And we're looking forward to dive deeper into the examples of how to apply biomimicry in healthcare industries and in the world at large. Hopefully you get some good takeaways for your work in the healthcare industry. And we hope you enjoy the conversation. All right, Ayla, pleasure to have you back on the Sustainable Healthcare Podcast. Last time we talked about some of the general applications and defining what is biomimicry. And today we're really looking forward to dive into some deeper examples of how can this principle be used in the healthcare sector and more broadly other ideas as well. So really good to have you back, and I'm looking forward to this conversation.
Thank you, Lasse. It's good to be back. Looking forward to digging in.
Amazing. And so I think at this point it would be great to narrow the focus a bit on the healthcare industry specifically. And I'm curious if you could give some examples of different areas of application for biomimicry in the healthcare system. I'm thinking specific medicines, or can it be used in devices or delivery methods for certain active product ingredients? Like where could you see biomimicry play a role in the healthcare industry?
Well, honestly, I can see biomimicry really working in all of the areas that you just mentioned. Because again, like all of these functions that we're trying to accomplish, whether it's the delivery of some medication into various parts of our body, or a medical device, if we're trying to reinforce bone structure or what have you, like all of these functions are found in nature. So in my opinion, biomimicry can really be applied across all of the different areas, or most. Maybe saying all is a little bit too risky, but to most areas of healthcare, we can apply biomimicry. And we can apply biomimicry for innovation, so developing a product that can be used in our healthcare system. But we can also mimic the aspects of nature that make nature sustainable. And so we can use biomimicry for both innovating a product and for sustainability.
Coming back to the sustainability in just a little bit, I'm just curious if you could, or if we could maybe together think up a couple of examples of where you've either seen biomimicry being employed in a specific product development or an innovation cycle, whatever it might be, or have ideas for products or processes where you could see this being applied. I'm just thinking to paint a bit more of a detailed picture or getting a bit more texture for when we say that biomimicry can be used in the development of a new medicine or in the application method of an existing product or whatever it might be, to give a bit more like a tangible example of what could that be.
Yeah, for sure. I was actually thinking before the podcast of giving a very general example. It's not in healthcare, but it's something that everyone can relate to, and then giving some examples in healthcare.
We love both.
Yeah, so one biomimetic technology that I think everyone is familiar with is Velcro.
How so?
So Velcro, I think some, like maybe in France they call it Scratch, or it's the very nice, I used to have Velcro shoes when I was in elementary school, and sometimes was kind of embarrassed that I was still wearing Velcro shoes, but my mom would...
Best part of childhood, I'm sure. Most can agree.
Yes. Now it's hip. But so Velcro is, as I said, a biomimetic technology. There was a Swiss electrical engineer, and he was also an inventor, Georges de Mestral, I think is how his name is pronounced. And this was in the 1940s. He went on a hunting trip with his dog into the Alps. And when he came back home, he came down from the mountains after his hunting trip, he had a bunch of burdock burrs stuck to his dog's fur and to his clothing. And burdock burrs, just to explain, burrs are essentially seeds that are covered with spikes. And, if you've gone out on a hike or something, you've had these they're just small little round seeds, spiky seeds that stick to your clothing. And he thought, oh, well, this is interesting because they stick very well. And he looked at the burdock seed or the burr underneath a microscope, and he saw that, oh, these burrs, the little spikes that are sticking out of the seed, they all have hooks at the end of their spikes. And he then looked at some fur and fabric and saw that there was kind of a loop structure of the material. And so he realized, these seeds with their hooks are really good at attaching to fabric or dog fur that has loops. So he then created this hook and loop adhesion system, which we now know as Velcro, and he patented that, I think, in the 1950s, and then went on to create a billion-dollar company, and we all use Velcro today. So that's one example of bio-inspired innovation or biomimetic innovation, where he observed something interesting in nature and then he mimicked that in a synthetic material. Okay, so it's an innovative product. Is it sustainable? Well, maybe not, because Velcro doesn't biodegrade. And maybe it's synthesized or created using chemicals or other materials that may not be so great for the environment.
But the function here is mimetic, and then like mimicking the decomposition of a natural product would probably be another aspect of biomimicry in this case.
Exactly, and of course it's a lot more challenging, but that's what we have to be working towards. It's much easier to mimic a form or a process in nature using whatever materials we want. But the next challenge, and we see that today, that this is an essential need, is to not just mimic the forms or structures in nature for the sake of just innovation or solving a problem, but we have to also incorporate nature's sustainability principles and mimic that as well when we're trying to design something.
So also
and not too long ago,
you could even maybe say like to mimic a life cycle process, in the sense that in nature everything has its own specific life cycle, and usually a growth and development and a rigidity, and then usually also some decomposition and decay, and that process as a life cycle could be applied in other fields as well as a part of innovation, I guess.
Absolutely. Yes, absolutely. And I was just reading not too long ago that some Italian scientists from the Italian Institute of Technology, quite recently, I think in 2021, they created the first prototype of a biodegradable Velcro that was also inspired by nature. And it's not necessarily for the same applications as we're using today, but they were inspired by a type of plant. It's called the catchweed plant, that has these micro hooks on the surface of its leaves, and it's able to attach itself to other plants that are growing. So it uses other plants as a structure and it grows on top of them. But it kind of inserts its hooks into the leaves of other plants to be able to grow on top of them. And so they mimicked this, and they used 3D printing and some sort of sugar or some sugar-like substance that would degrade easily. And so they're using this application, this biodegradable Velcro, to attach, I think, to plants for sensors, as environmental sensors, but they're also using this as kind of a delivery system because these micro hooks go into the leaf and connect with the plant's vascular system. And so they're able to deliver medications into the vascular system of the plant to help it maybe be stronger, more resilient under certain circumstances. I'm not totally sure. But it made me think of also that we're using today microneedle patches to transdermally deliver treatments to humans. So who knows, this could be a source of inspiration for a biodegradable patch that we can use to deliver treatments to humans. So that's kind of a general biomimicry example that we're all familiar with, Velcro. But then there are many examples and different types of examples or different areas of healthcare um, that have been inspired by nature. Some are already out on the market. There are a lot of ongoing studies towards getting to the market. So we have a mix of different technology readiness levels. But something that's on the market, for example, and that's quite local to me, um, is a company called Tisium. They're based in Paris, although the work I think was based on research that was done at MIT in the United States. And what they were trying to find was a way to create surgical adhesives that would be able to function in a very wet, dynamic environment, so inside the body. And yeah, and for quite some time, it was a real challenge to be able to create an adhesive that developed in a wet environment, like an underwater adhesive, for example. And so they wanted to create this surgical adhesive. It had to be compatible with the body. It shouldn't mix with the blood when it's applied, and it needed to stay put where it was applied. So if it was applied to close up a hole in the heart, for example, it should stay put where it was applied and not spread to other parts of the body. So this was, of course, quite challenging. And they sought out some inspiration from nature, and nature was able to deliver because the function of adhesion underwater exists in many different species in nature. So they looked at a variety of different organisms that create their own adhesives from snails, but then also looking at adhesives that need to function in wet environments. So they looked at like blue mussel is a well-studied organism that creates adhesives in wet environments in seawater. They also found an organism that's quite interesting called a sandcastle worm, and they live in intertidal zones. So that's where, like on the shores of beaches, where the tide will rise, and sometimes they'll be covered with water, and other times when the tide is low, they'll be exposed. And this is a challenging environment because you have the salt water at times, waves, there's a lot of different forces at work. Sometimes they're exposed to sunlight, etc. And these sandcastle worms, they essentially build their own homes, and they'll use grains of sand, so these tiny little grains of sand, and they'll build tubes out of these grains of sand, and they'll live inside the tubes. But they're having to build their homes, these tubes, using grains of sand in a wet environment. So they have a special adhesive that they're able to use. It's almost kind of like they take bricks and mortar and build their little homes. But this adhesive that they use is really impressive because they're able to build their homes underwater or in these wet environments. So that was a great source of inspiration for these scientists. And they were able to create, using this bioinspiration and studying how these different organisms are able to create these underwater or water repelling adhesives. And they created a synthetic bio-inspired polymer to use in this surgical adhesive. So they're able to really have a lot of control with applying this adhesive to a particular part of the body. And they're able to apply it in a very wet and dynamic environment, such as I think when they were first testing it out, they used like a pig's heart that had a hole in it, and they were able to seal up this hole in a beating pig's heart. So it was a dynamic wet environment, but it functioned. And they use light with a specific wavelength to convert this adhesive from something that's viscous to more of a flexible solid that is able to biodegrade over time and be absorbed by the body.
So this is a product that is on the market, you could say, and
Yes.
is functioning in real world environments that has a direct nature and inspiration, you could say, in how it functions and in the purposes and the ways that it, like the principles that it needs to adhere to in its function and form.
Yes, exactly. And so now we're not needing to rely as much on staples or sutures to do the job of fixing cuts or holes in the body. We can on organs or veins, we can use this type of bio-inspired surgical adhesive.
I could imagine this having a lot of potential in anything where you're trying to engineer the human body and engineer the human environments or the human body as an environment in terms of prosthetics and any kind of interventions or surgeries where you have to go in deep and either replace or augment certain parts of the human body, and you have to have that interface between technology and biology, which has been a challenge for years now. And I could imagine biomimicry playing a big role in at least establishing the first principles that a design process then employs in developing these products.
Yes, absolutely.
Do you have other examples on hand or anything you could think of where biomimicry could be applied in the healthcare sector, but maybe on a more micro or molecular level even?
Yeah, one area is that people are working in is surface microtopography. So it's at the micro scale. And there's a company called Sharklet that's creating a bio-inspired product that is on the market already. And Sharklet, it essentially mimics shark skin. And on shark skin, they have what's called dermal denticles. They almost look like shingles on a roof. They're diamond-shaped shingles that are kind of layered like they would be on a roof, and they have ridges on them. The surface structure is on the micro scale on the shark skin. And what made them first become interested in shark skin is because they observed that a lot of other marine organisms, like whales or sea turtles, have algae or barnacles that attach to them. But they saw that sharks were different. They didn't see any barnacles or algae that would stick onto the surface of shark skin. So they thought, oh, this is kind of interesting. And at first, their initial application was to prevent like ships from getting all of these organisms stuck onto the walls, the external walls of the ship, because that would increase drag and require more fuel to power the ship. But then they realized, oh, there's another really interesting application, and that could be for protecting surfaces from bacteria. And yeah, and so they did some experiments, and they found that using this pattern, this microtopography that they found in sharks, they're able to prevent bacteria from landing on the surface and forming biofilms. And biofilms is a big problem when it comes to like surfaces in hospitals, but also for any surface like that's inserted inside of the human body, whether it's tubes like catheters or implants. Bacteria tend to adhere to those surfaces and form biofilms, and it's very difficult once they form biofilms to get rid of them. And antibiotic treatments are often not effective because these biofilms, they'll almost form like a protective coating that prevents antibiotics from being able to enter deep into the biofilm and kill bacteria. The trick is, hey, let's prevent biofilms from forming in the first place through changing the surface structure of an implant, tubing that goes inside the body, or surfaces in a hospital that are touched often by human hands and where transmission of bacteria can easily happen. So yeah, they created these films that they're able to apply to different surfaces that mimic the microtopography of shark skin. And this specific surface structure, it requires too much energy for bacteria to be able to colonize on those structures. So they can't. And so they found that they were able to inhibit the growth of like Staphylococcus aureus or E. coli or MRSA, like all of these bad bugs that we try to avoid when we're in the hospital. And they're able to do that without using any type of chemical intervention. So they're not killing bacteria, they're not using antibiotics, so they're not contributing to the creation of superbugs, which is a big problem today, these antibiotic-resistant bacteria.
So there's an off-road here that leads into the field of preventive care, which, I mean, we know that has a huge potential in terms of sustainability, because the treatment that you never have to make is the treatment that, of course, emits the less greenhouse gases and uses the less resources of in overall.
Yeah.
And I could see a huge potential for sustainability impact in terms of preventive care if you're able to prevent a certain set of diseases from forming due to having cleaner surfaces or whatever it might be. But could you maybe give examples of other areas where where you could see a sustainability impact from biomimicry or from biomimetic solutions?
Yeah, and that's a that's a good question. And to be honest, I think there are maybe less very obvious examples of that, because I think up until now, most of the biomimicry that's been done has been to really solve a particular problem with some type of innovation with a product, and less attention has been given, I would say, thus far to the sustainability side of things. But of course, there are people trying to really think about how we can use biomimicry for sustainability, both in terms of developing the actual product itself, but then also thinking on more of a systems level, how can we even make infrastructure, for example, that's more sustainable? I mean, healthcare has to, the products of healthcare need to be manufactured somewhere. Um, and everything, I mean, not just in healthcare, obviously, everything we produce has to be produced somewhere. In order to produce something, we're creating factories. Those factories are on land. That land is replacing, or the factories are replacing natural ecosystems that were on that land before. And what we're not replacing when we cut down, let's say we cut down a bunch of trees on some wilderness area and we replace that with a human system, we're not replacing the ecosystem services that that land was providing before. And to me, this is kind of the crux of sustainability. And nature is, in my opinion, the definition of sustainability, or it's at least our ultimate benchmark for sustainability. And when I say nature, I'm talking really about biological organisms. I mean, because of course you could say, well, in nature there was the ice age and a bunch of species went extinct, etc. But when it comes to actually looking at biological systems, they function in ways that don't create massive amounts of pollution, or that incorporate all of the buzzwords that we hear today, like circular economy. I mean, biodiversity, all of these are an inherent part of nature.
Yeah, so we're talking about an equilibrium here, about an equilibrium of the different bioorganisms that are in a system and how they interact, and how energy is kind of preserved or maintained inside that system in a circular way, you could say, as a source of inspiration for on a systems level. I'm thinking also from hearing you speak, I'm thinking also of an example where I'm imagining that some chemical waste from pharmaceutical production, or bio-waste from medical facilities, hospitals, waste in general that can be difficult to treat and degrade certain chemicals. Maybe I'm imagining there might be processes out there where we could find solutions for some of those treatment systems by mimicking how certain elements are treated or integrated or broken down in natural environments. How would you feel about that?
Oh yes, absolutely. So we can really try to approach this on all levels. Of course, we start with the low-hanging fruit, what's easiest to do today. But then we have in mind what we would like to do in the future. Even if we don't have the technology or capabilities of doing it today, this is what we should be working towards. So first, we can try to work on treating the pollution that we generate using bio-inspired methods, because there are lots of species that are able to break down complex, they can deal with complex chemistries, or also with nanoparticles, for example. I mean, there are ways that micro and nanoparticles are managed in nature. We can emulate those strategies to try to manage our wastes as best as possible, but then we can also work upstream. And this is maybe the more challenging part, but what we need to be working towards is how can we create products that in the first place don't result in massive amounts of pollution that's difficult to treat in the first place.
I see that point. I think it's an interesting case of you could say we're trying to be pragmatic and solve the problems that we have here now. You could say we're trying to find the low hanging fruits, and at the same time, I should say, what if we thought, in a bit more of a big picture kind of way where we don't have the problems in the first place, or we try to redesign the process or the system from a first principle of how do we generate less of that hazardous or hard to treat pollution or waste in any of our processes. I think that's really
Yeah,
interesting. Yeah.
exactly. And it goes back to what you said earlier about prevention and yeah, can we prevent creating these harmful substances in the first place? And I think that's the ultimate goal. Of course, we can try to treat the disease or we can try to treat the pollution, but let's work towards not creating that pollution or allowing that disease to take hold in the first place.
Could you talk a bit about what are some of the key barriers or concerns when doing biomimicry or when trying to integrate this in other fields? What are some of the largest barriers that are usually encountered or some concerns that usually arise?
Yeah, I would say there are two main barriers at this point in time, although fortunately things are shifting. But I would say the two barriers, the main ones, and these are ones that I personally encountered in my work, is both nature is really complex. Can we fully understand? There we can recognize some really cool functions that are happening in nature and things that we would like to be able to do. But of course, a lot of things are that nature does is very technical, super high tech, and we don't necessarily have the knowledge yet or the tools to be able to figure out how nature accomplishes some of these functions. But maybe that's just a matter of time. I mean, we've already come a long way in how we're able to look at nature and understand it and how things work. So that's improving all the time, and we're learning more and more. Our capacities, our capabilities are increasing. So that's great. The other main obstacle that I see always comes down to cost. And sometimes or a lot of times the biomimetic technologies that we could be going towards are more expensive than what's being done today. And that's another aspect or a tricky part. How can we find solutions that are biomimetic or bio-inspired that are doable or within a company's budget?
So there's a process of not only recognizing what is the function in nature that we're trying to emulate here, but also saying once we have a minimum viable product of this function, of this biomimic solution, how do we simplify it and boil it down into something that is scalable and cost effective and competitive with similar solutions that are already on the market and maybe less holistic in their scope?
Yeah, exactly. And yeah, I think that's a big challenge is just overcoming the cost equation.
Yeah. And do you think that prohibitive cost is mainly due to the fact that when you want to do or when you're thinking about a biomimetic solution, that you kind of have to go to a more fundamental research level and think things through and start over basically in your design and have a more clean approach to a first principle design thinking? Do you think that's the main part of the cost drivers there, or is it more that the solutions that are developed in through biomimicry are more complex usually?
Yeah, I think it could be both. It could be on the upstream innovation part where a lot of fundamental research needs to go into being able to figure out a biological mechanism and understand it enough to make a translation into a product. But then there's also the part of, okay, once we've developed a really cool product, do we have the manufacturing capabilities today to create this new product? Do we have to change or retrofit somehow the way we make things? Because a lot of times nature makes things very differently. And if we're trying to emulate both a mechanism, but also the way nature makes things, which is usually more sustainable than what we're doing, that's going to require some changes. There is the cost on like across, I would say across the product development cycle that has to be considered. Anytime you do something new, it's going to require a little bit of an input of energy to first figure it out and get things going. But maybe that's just something we have to say, okay, we're going to have to make this investment. We're going to have to spend a bit more money up front. And of course, when I'm talking about cost and companies, being reluctant to spend more money on a biomimetic technology versus what we're doing today, this is really short-term thinking, of course, thinking about costs today. But if we're degrading the environment and, we're losing ecosystem services, the costs of that are going to be massive. And so we need to factor in all of that into the actual cost of producing a product or providing a service, which we're not doing as much today, but we have to. So in that respect, maybe ultimately biomimetic products would be a lot cheaper because if they're done well and in a way that's supportive or life friendly, then we're going to be able to maintain our ecosystems better. We won't be disrupting ecosystem services as much. And, ecosystem services are everything. We're getting oxygen, clean water, food, medicines from these services that ecosystems provide.
And we might even surmise that companies developing more biomimetic and more holistically minded or in general more sustainable solutions would also be more sustainable in the sense that they will have a license to operate in the future and they will be competitive in a different way because they have something on offer that is taking into account the long-term perspective of the systems that they're a part of, not just the short-term profit gains.
Exactly. Yeah. And that is biomimicry because organisms are they're living to survive for generations and generations and generations to come. It's not a short-term thinking that has kept 3.8 billion years of life going on Earth. So, yeah, organisms can
It's a meticulous process.
yeah, and companies can think about their sustainability in terms of how long their company is going to last in the same way, just as what you said.
Uh-huh. Looking ahead, where would you like to see biomimicry applied in the healthcare sector going forward? And here, I mean, we're allowing some flight of fancy. We can move a bit beyond the scope of what is actually in the labs right now. I think I'm just very curious. Where do you see this applied and scaled in the healthcare industry?
Gosh, that's a good question. I mean, I really, of course, want to see more emphasis on sustainability and systems thinking, which I think biomimicry is a fantastic tool for that. Probably that's the most urgent need or area. I mean, not thinking just about healthcare innovations or products, technologies, but thinking more on the sustainability side. Can we take care of ourselves while also taking care of the planet? I think we just have to put a lot more energy, attention into that.
Amazing. I think I'm at the point where I think it would be good to wrap this up.
Yeah.
Do you have, Ayla, any closing remarks that you would like to add for the listeners?
Think about how nature would solve problems and, just start looking around a bit more at the nature that surrounds you, whether you're in a city and you have a local park or you're walking down the street and there's some weeds growing up from some cracks, just to start observing more and feeling more of a connection to nature. That's something that when I started studying biomimicry, I I started to see nature in a very different way. Like, wow, that's not just a tree, which it's beautiful. It offers shade. It's lovely green color. But that tree is an oxygen producing factory. It's a filtering machine. It has an incredible pumping system without an actual motorized pump. I mean, you start seeing nature in a very different way and appreciating everything. I mean, I see a mosquito and I'm like, wow, that thing's incredible. And beetles, I probably look a little bit weird when I'm like crouched down on the sidewalk looking at a cockroach or whatever. But yeah, I mean, everything is just incredible. And every species that I've ever encountered or studied has some kind of superpower and something that we can learn from. So, yeah, look around you, enjoy nature, get outside more, or watch cool David Attenborough movies about nature.
That recommendation has definitely been passed on, and I can second that wholeheartedly. I think not only having a system level awareness, but also a system level or appreciation of the different aspects of a system, I think is something that is something we can all learn from. But Ayla, thank you so much for your time today and for inspiring us with these points about the potential in biomimicry and nature-inspired innovation. I think this is really something that we will see a lot more of, both in the world at large, of course, in research, but hopefully also in a commercial side of things. I am hoping that companies will take note and move further in that direction. So thank you so much for joining us.
Thank you, Lasse, for having me here. I appreciate it.
Thank you for listening to this episode of the Sustainable Healthcare Podcast. We hope you got some takeaways for your work in the healthcare industry, and we're hoping to see you again on the next episode. If you would like to learn more about what we're doing with healthcare sustainability, please visit greeninnovationgroup.com or reach out to us on LinkedIn. We're happy to get in touch. See you next time.